Guys, my name is Ali. I just wanted to share with you this very interesting ECG, which was taken from a book called Atlas of Electrocardiography by Dr. K. Wang from the University of Minnesota. So, when you look at this ECG, you can appreciate that it doesn't look like a normal EKG here. So, for example, for a variety of reasons, if you look at V1, you have a very massive ST segment elevation. Same thing with V2, and in V3 to a lesser degree. You can also appreciate a tall T wave in most leads actually. And when you look at the rhythm strip, you can appreciate you have wide QRS complex and the disappearance of P waves except this P wave here. So what's going on here? So if you look closely at V3 and V4, you can appreciate you have narrow, tall, and pointed T wave. This looks different from the hyperacute T wave that you see in acute myocardial infarction, which looks like a wide and fatty kind of T wave. So this narrow T wave, tall and pointed at the end, in combination with the wide QRS complex, this pattern is typical for hyperkalemia. So if this pattern is hyperkalemia, so why are we having ST segment elevation here in V1, V2, and also V3? If you look closely, you can appreciate there's R wave, first R wave, then S wave, then second R wave. So coming from the second R wave, the ST segment is downsloping and ending into inverted T wave. The same thing is happening in V2. This pattern is called Brugada pattern, which is an acquired Brugada pattern because of hyperkalemia. The reason for that, because in severe hyperkalemia, the potassium inactivates the sodium channel, which creates a pattern similar to Brugada syndrome, which is a sodium channelopathy syndrome. The other thing, when you look at the rhythm strip, you can appreciate the disappearance of P waves. So why is that happening? So as the potassium levels increase, so you will most of the cells in the atrial myocardium will be inexcitable. So the electrical signal from sinoatrial node cannot excite the cells in the atrial myocardium. So the B waves get flatter, flatter, flatter as the potassium levels increase until you see disappearance of B waves. We can also appreciate only one B wave here in this rhythm strip, and you can also appreciate there's very prolonged BR interval from this P wave to this R wave. This prolonged BR interval is also typical for hyperkalemia. So why we need to know this pattern of hyperkalemia? Why don't we just like order potassium blood levels? There are actually two reasons for this. So this patient could be coming with acute renal failure and increased potassium. So the last thing he needs you to do is to inject him with a contrast, just to do angiogram, because you might suspect ST segment elevation myocardial infarction here. The other reason, you need to treat this patient with calcium just from looking at this ECG without potassium result, because this pattern is progressive, so it can rapidly progress into sine wave and ventricular fibrillation, and the patient will die. So this pattern is very typical, and like you'll see it over and over again in many ECGs. So just know this pattern: tall, narrow, pointed T wave in combination with wide QRS complex. This is typical for hyperkalemia. Okay, thank you very much.